This is lesson 5.1 and 5.2. We're going to be talking about triangles. So first we're going to talk about the triangle classifications. Triangles can be classified or named by their sides and by their angles. So there are three ways you can classify a triangle by its sides. Scalene is when there are no congruent sides in the figure. Isosceles, by definition, is at least two congruent sides. Usually we'll only look at two, but the definition does say the word at least, which makes an equilateral triangle with three congruent sides a type of isosceles triangle, but does have a more specific name, so we'll use that. Equilateral, all three sides congruent. We could also classify triangles by angles. So an acute triangle is when all the angles are just acute angles. They could be different, they could be the same, doesn't matter. A right triangle, when you have one right angle, the remaining two angles would have to be acute. An obtuse triangle, where it has one obtuse angle, the remaining two angles would be acute. And then equiangular triangle. So just like before, this could be called an acute triangle, but it does have a more specific name when all three angles are congruent to each other. So we're just going to classify each of these by its sides and its angles. So in A, we see we have two congruent sides, so that would make it isosceles. And we do see a right angle, so that would make it right. Generally speaking, we write the angle before the sides. It just sounds right. Isosceles right sounds different than right isosceles. It doesn't matter how you describe it, but typically I write the angle first. So in B, I'm going to do the angle first. So we see an obtuse angle here, so this is an obtuse triangle. And it doesn't give us any indication of congruent sides, whether there are or not. There could be, but if they don't tell us that there are, we're just going to have to call this scalene. And then this last one, we see that all three angles are the same. Okay, I couldn't remember if I said the word equiangular or not. Sorry. So equiangular is when all three angles are the same, and all three sides are the same, so it's equilateral. So this is equiangular and equilateral. There we go. Triangles have both interior angles and exterior angles. So the interior angles are the angles, like if I didn't see any of these pieces here, they're just the angles inside the triangle. But if you extend the sides of the triangle, you form exterior angles. We'll first focus on the interior ones. So the interior angles of a triangle add to 180 degrees. That is called the triangle sum theorem. And there's a little offshoot to that triangle sum theorem, which specifies only in the case of a right triangle that the remaining two angles would be complementary. So that just saves us a little time. If you know the triangle's a right triangle, you don't have to add all three to 180. You could just take the two remaining angles and add them to 90. And that's what we'll do in example 2. Find the measure of each acute angle. Since it's a right triangle, I know the remaining two angles are complementary. So I'm going to add those two and equal it to 90. So we have 8x plus 2. So 8x is 88 and x is 11. And we still want to find the measures of the acute angles. So if I did 5 times 11 minus 2 and 3 times 11 plus 4, I get 53 degrees and 37 degrees. And that makes sense because 53 plus 37 is indeed 90. All right, example 3. We have two different variables in the triangle. So this is actually going to end up as a system of equations. I'm going to start in one triangle here. I'm going to start here. And I know that these three angles should add to 180. So that's going to be 3x plus x plus y equals 180, which if I simplify is 4x plus y is 180. And then I have a larger triangle. Let's erase the blue one. And I have a larger triangle here. So one of the angles is 65. This whole corner angle is both the 11 and the y. And this whole corner angle is both the x and the 11. So if I wanted to simplify this up, we would have x plus y plus 65, 76, 87, which is also x plus y equals 93. So this is our system. I can solve by substitution or elimination. I'm going to do elimination because I already have a y and a y, and I can easily make one of them negative. So let's say we multiply this whole equation by a negative 1. So that's going to give me my original equation up here, 4x plus y equals 180. And my new modified equation here, negative x minus y equals negative 93. So we get 3x, the y's cancel, equals 87. So x is 29. And then we're going to go back to one of our original equations. This one looks good. X plus y equals 93. So we're going to do 29 plus y equals 93. And just take that 29 away, and I believe we get 64. All right, and that's that problem. So you can go ahead and try this one if you'd like. Pause. The answer is posted online. So now we have the exterior angle theorem. And the exterior angle theorem is saying that the measure of the exterior angle is equal to the sum, right, addition, sum of the two non-adjacent interior angles. So of the three interior angles, the one next to one is adjacent. These two angles over here are the non-adjacent angles. So I like to think of it as, let's put some variables, some little a and b. So a plus b equals angle 1 outside here. So they want us to find this angle 1, which is an interior angle, but to do that we're going to have to find x first. So I'm going to set up my equation where the sum of the two non-adjacent interior angles is equal to the one that's exterior. So 40 plus 3x equals 5x minus 10. So I could take away the 3x, I can add the 10, so we get x is 25. And if I put that back in, either to this angle or these, let's put it in here. 5 times 25 is 125, minus 10 is 115. These angles here are a linear pair. They make a straight line, right? They're adjacent. So I know that they add to 180. They're supplementary. So 180 minus 115, measure of angle 1 equals 65 degrees. Here's a try problem. Pause it if you'd like. The answer is posted online. Example 5, another exterior angle problem, but this time we have an x squared. But nothing's going to change about how we set it up. We're still going to add the 2 that are inside and set it equal to the 1 that's outside. So that's going to be x squared minus 1 plus 4x minus 3 equals 5x plus 2. So you know once we have quadratics, if there is an x squared and an x, we want to get it equal to 0, so we could solve by factoring. So I'm going to minus the 5x minus the 2 and combine some like terms all at once. So that's going to be x squared minus x minus 6 equals 0. So I'm looking for the two numbers that multiply to negative 6 and add to negative 1. That's a negative 3 and a positive 2. Right? Negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. So my solutions are x equals positive 3 and x equals negative 2. And now I have to just check to make sure they both work. So let's say I took the x equals 3. 5 times 3 is 15, plus 2 is 17. That's a positive value. X equals 3 works. If I tried negative 2, 5 times negative 2 is negative 10. Negative 10 plus 2 is negative 8. I can't have a negative angle measure, so that's an extraneous solution. So my answer is just x equals 3. We've talked about congruency before when we talked about congruence transformations. So we're going to focus very specifically now on congruence and focusing on congruence statements and the parts of the figures that match. So we have corresponding angles. The angles that are congruent to each other in the figures are considered corresponding angles, and the sides that go with each other are called the corresponding sides. And we write congruence statements based on this information. So knowing that A matches with D, if I wanted to make a congruent statement for the triangles, A and D would have to be in the same positions in the statements. If B matches with E, then B and E should be in the same positions, and if C matches with F, C and F should be in the same positions. We can go both ways. If we know what the picture looks like and we know what angles go together, we can write the appropriate congruent statement. Or if we have a congruent statement, we can identify the corresponding parts. And there's also something called the third angles theorem. This is mostly a common sense theorem. We're not going to use it all too much, but basically if I already know that two angles are the same in the triangles, the last angle also has to be the same. So here we're going to show that the two triangles are congruent. The only way right now that we know that triangles are congruent is that every single pair of corresponding sides is congruent and every single pair of corresponding angles is congruent. So in our picture, we're already given all three pairs of corresponding sides. We don't have to do anything about those. I can also show that we have a pair of vertical angles. So that's one pair of angles that's congruent. And then we also have these parallel lines, right? We know they're parallel because they're giving us the little triangles on them. Anytime we have parallel lines in a shape that looks like a bow tie, we're going to end up with alternate interior angles that are congruent. So this angle here at S would match this angle here at Q, and this angle here at P would match this angle here at R. Notice I use different kinds of markings for my angles. It is very helpful to have that because if I want to write a congruent statement, I need to know that I didn't mark S and P as the same and Q and R as the same as both of these, because then I wouldn't know which one goes with which. So I do know the triangles are congruent to each other because I've been able to prove that every pair of angles matches and every pair of sides matches. So we are now just going to write our congruent statement. Ideally, when it says show that the triangles are congruent, we would write out everything we just did. But for our purposes right now, we're just going to say it, explain it, and then write our congruent statement. So let's say I'm going to start this one PTS. When you're writing a congruent statement, it does not matter how you start it, unless it's already the starting is already given to you. So you can make the first triangle any order you want, but now the second one has to match what you did in the first. So I started with a P, which I marked with 3. So I'm going to start with R, which is what I marked with 3. Then I went to T, which would had 1. So then T has 1, and then S had 2, and Q has 2. Right? If I had started this SPT, then I would have had, let's say, SPT, QRT. So it's very possible for you and I to have two different answers for this and both be correct if we started with a different order for our first triangle. So you can go ahead and try this one. It's just asking you to write the congruent statement. Pause if you'd like. The answers are posted online. All right, example 7, we are given a congruent statement. So we know that these two figures are congruent, and I want to find the value of each variable. I see that this side QR has a 2x minus 4. If I look at my congruent statement, QR are the last two letters of the statement, which means FG should be the side that matches with QR. So I could say that 2x minus 4 equals 12. So that's going to be 2x equals 16 and x equals 8. So then my other variable, I have a y here in angle Q. So Q is in the third spot. That should match with F in the third spot. So 6y plus x equals 68. I already figured out that x is 8, so let's plug that in. Substitute it in. So now I can take away the 8 and divide by 6. So y equals 10. Here's try 7. If you'd like to give it a try, pause. Answers are posted online. Here's example 8. So we see that angle A and angle B are congruent. Angle BCD and angle ACD are congruent, which would also mean that the third angles of the figures would also be congruent. So angle ACD would match angle BDC. And they're asking me to find angle BDC. I don't know any angles yet in this figure, but I do know both angles in the other. So if I know angle BDC should match angle ACD, I'm going to actually find angle ACD. So I can say that x plus 45 plus 30 equals 180 using the triangle sum theorem. So I get 105, which means that the measure of angle BDC equals 105 degrees. The last problem is a try. Go ahead and give it a shot. The answers are posted online. But this is the end of sections 5.1 and 5.2.